Welcome to this episode of Let's Be Civil. Scott Beisler joins me today on Let's Be Civil. Scott Beisler is the director at Delta Consulting Group, a construction claims firm serving the domestic and international markets. Scott has over 30 years experience in preparing and defending construction claims for contractors and owners and for all types of construction projects. Scott received a bachelor's degree in civil engineering from Lafayette College and a master's from Lehigh University. Okay, welcome everybody to our next edition of Let's Be Civil. And Scott's with me today, and Scott and I have known each other for onwards of 35 years. But this is the first time we've been able to see each other and talk in those 35 years outside of LinkedIn exchanges and email exchanges. So I'm excited to get a chance to talk with Scott again today, and I'm going to so Scott's going to be another one of those people. Now he is a civil engineer, but he works in a very different kind of world within civil engineering. So I'm going to let you give us a little bit of background on yourself. And where you are today, and what is it that you actually do? So to me, it's fascinating.
All right. Well, thanks for having me, John, and
Sure.
see you again after 35 years.
Yeah.
We did have a couple phone calls too, where I was poking your brain for information. But just to give a little background on myself, I became interested in the construction industry because growing up, there was the housing boom in North Jersey in the 60s as everybody was migrating out of New York and the big cities. And as homes were being built, I took an interest, and that got my interest in architecture. And I took all the courses in high school, mechanical drawing and architectural drawing. And I thought I was going to be the next Mies van der Rohe. And I got into architecture school, and after 2 years, I kind of got the feeling that this wasn't cut out for me, and maybe I should look into another field in the construction industry. And
Where did you go to school for architecture?
I started out at New Jersey Institute of Technology
Okay.
in Newark, New Jersey, having
Right.
from North Jersey, just north of Giants Stadium. And luckily, NJIT had long been known as Newark College of Engineering before that, and was a very good engineering school. So all I had to do was walk down the hallway and talk to the civil people, and I had already taken some intro engineering and civil courses. So I transitioned over to civil engineering, which I ultimately decided thereafter to transfer once again, this time schools, to get the full college experience as opposed to being in downtown Newark. And I transferred to a small college along the Delaware known as Lafayette College in Easton, Pennsylvania, where I met another colleague and friend of ours. We also knew at Lehigh, and we'll get to her later. And I finished my degree in civil engineering, was one of the winners of the top civils in the program, and I interviewed, and it was a good time for building back then. It was right before the recession in '81, and I got a job with Bechtel, world's largest engineering and construction company.
Mm-hmm.
And I, since I had taken that first step to move away from home and go away to college, I figured, well, why not move halfway across the country to Houston, Texas, and start working for Bechtel Petroleum. And so I'm also spent some time in Texas, where John is now headquartered. And Texas was quite a eye-opener for me, having been from
I would bet. I would bet.
saw a lot of Texas while I was there, enjoyed it. But working for Bechtel, they take on the world's biggest projects. They're complicated, they're complex, and they're difficult. And it was quite eye-opening to see what it takes to build to design and build in my case, it was a coal gasification plant. Turned out to be the first commercially operating one in the country for Eastman Kodak. And after the job had made enough progress in engineering, I was moved to the field. And although my degree was in civil engineering, I took a job at Bechtel in something known as project controls, which is cost engineering, planning and scheduling, estimating, risk analysis, cost forecasting, which is very common for engineers to do because you need to understand the basic principles of engineering and construction to be a scheduler or a cost engineer and understand production and productivity, et cetera. So when I moved to the field in Upper East Tennessee, got to, another great experience, seeing another part of the country, beautiful country, Blue Ridge Mountains, but a very complex project that took several years to build. And I was in the planning and scheduling department, and we were using something known as CPM, Critical Path Management, which is computer-based. That's come a long way in the 40 years I've been involved with it. But that's where you model a schedule by putting activities with logic ties and restraints between them. And you may have a schedule with 200 activities or 10,000 activities. And it will tell you what the longest path is from time now to project completion. And since schedules are very dynamic and projects are dynamic with a lot of changes, and sometimes things make progress, some things don't, or sometimes there's a big change and you got to change course and reschedule the job. At least you know what's known as the critical path. And you'll probably hear that term a lot if you get into engineering. Time is money. If something's late and you don't finish on time, well, it costs everybody money. And we'll get into that a little bit later when we get into more details. But back in the day, scheduling was done with bar charts, but they weren't very accurate. But with the computer, at least there could be a better sense of accuracy with showing all the logic ties as opposed to 10 or 15 bars on a 24 by 36 schedule.
So this was in Tennessee.
You update the schedule every month, and you start to learn about construction because you see how things are interrelated between the need for materials, the need for engineering drawings, and the need for whatever the construction constraint may be, whether that be having access to that part of the project, or having a foundation to put the steel on, or having pipe delivered before you can start installing the pipe, or having a 200-foot column, a piece of equipment that's used in refineries delivered. And all this has to be coordinated and input into the schedule so you pick up the entire scope of work of that project. If you don't have the entire scope of work in that schedule and in your cost records, you're going to be flailing and not really understand where you are and where you're going and how much it's going to cost. And something else happened in the 80s when I was involved on the contractor side. Things went from cost plus, where you'd sign a contract and it was whatever it cost plus a markup and profit for the engineering contract. Well, owners started saying, well, this is costing me a fortune. You guys have a blank check. So they decided, let's go to something called lump sum contracting, where you bid a hard number and a hard schedule date, and you've got to meet that, but for change orders that are approved by both sides.
Right.
And now the risk was placed back on the engineer and the contractor to get the design done and get it built on time. I mentioned time is money. And if the contractor didn't get it done on time, he was penalized at the rate of something really small for a commercial building to something very large for a power plant, which could be $180,000 a day because the power company isn't pumping electricity into the grid and making money.
Right.
And the longer he has to wait to do that, he wants to be compensated for that. Now, on the other hand, if the owner makes a lot of changes, the contractor is going to say, well, I didn't make my end date because you made all these changes. And then it becomes, first they would get negotiated on site, but then they became more and more complex, and the construction claims industry was sort of born as a cottage industry in the 80s. And now it's a thriving business because you can imagine how much things have gotten more complicated with technology and construction techniques and methods and all the other things that have happened in construction, like LEED, being green, having a lot of other complexities, and of course, environmental concerns. You can't flip that switch, get that project started until everybody agrees it's going to be safe and it's not going to pollute the environment.
So all of this basically led to where you are today. I mean, these experiences that you've had and this knowledge brought you to the career that you have now.
Yes, with one exception. We can't leave out John's part.
Okay.
I've done this with at Bechtel for about 4 years. I'd always had this inkling to go back to graduate school, thinking I might become a professor like John. And I got to Lehigh University, where I met up with John and a few others that we still stay in touch with. And we went through the master's degree in engineering before you go into the PhD program. But on the day I got to Lehigh, I found out my wife and I were pregnant. That was what we call in the industry as an impact. It was certainly an impact as well. And those $15 student insurance policies didn't cover babies. And so I had to change my plan. And I said, well, I'm here. I got the scholarship. Let me just finish the 2 years master's program and then move on, because now I've got 3 people to support.
Yeah.
I got that. I got my degree. I said, well, what am I going to do now? I decided I've already been on the contractor side, so I decided to go to the owner's side and work for a paper and pulp manufacturer. Paper sounds nice and pretty, and that nice coated paper you see in National Geographic, but paper plants are some of the dirtiest things you've ever seen in the world. They don't waste anything. Everything is recycled back through the plant. Any waste is recycled back through the plant and burned to help make power or whatever. So a paper plant is not just making paper, it's also got a power source on it as well. And a lot of recycling, and anything that's given off in terms of odors has to be cleaned. Because you can't put particulates in the air. So a paper plant is very complicated. And it was amazing when I went to some of these paper plants and saw how you actually made paper, from seeing the logs come in from the forest to getting the end product. And then the company's making a profit off it. And I was hired by my company to work on this specialized bleach plant, where they bleach the pulp so you can get nice white paper. And that got hung up in capital approvals. And I said, well, I can't wait much longer. Things aren't going on. So I reached back to my professor at Lafayette College, and I said, well, who else out there is looking? He sent me a couple brochures of people who had contacted him, and one of them happened to be this new company that did construction claims. It was a breakout from one of the big 8 accounting firms, and it started out doing commercial damages and commercial lawsuits like patent infringement, where Kodak is always suing Fuji or something like that. But they wanted to get into the engineering construction side because that was obviously a big driver of the economy. And there was a lot of capital projects going on at that time that were incurring losses. The reason how they got into it was during that period, there were a lot of nuclear power plants coming online. And before they could set what's known as the rate they can charge the users, the people like you and I who get their electric bill every month, well, the nuclear plant and power company owners, want to recover as much of their capital investment as possible. And they want to say, well, we spent X billion on this project. We want to put this all in the rate base so we can recover our investment. And then these things known as rate commissions may say, oh, no, you managed this project very poorly. So why should the rate companies, the users, the ultimate users, mom and dad at home, have to pay for all that? And that led to what was known as prudency hearings. And you had to reconstruct the project from start to finish and say, well, was this decision prudent? Was that decision prudent? And why did the schedule go from 4 years to 6 years? Because there's cost overruns that go with that. And we brought they added the engineering group to that, and a lot of people back in those days had nuclear power plant experience, and they could help with that. And then when they brought these people in, they decided, well, let's go after the rest of the market. Let's go after regular commercial construction like high-rise buildings or wastewater treatment plants or roads. There's cost overruns on every project. So that sounded interesting to me. So I went to interview, and the guy I interviewed with happened to also have worked for the same project manager that I worked for on that Tennessee Eastman project. Right there. And I ultimately went with that company and began doing what's known as construction claims analysis, either delay analysis or cost overrun analysis, because they go hand in hand. If you do a delay analysis and you find out all the problems were in piping, but the cost analysis says, oh, well, all the overruns were steel and concrete, well, you got a problem there. It doesn't make sense. So you've got to analyze both and see if there is any continuity in the losses and the delays. So
is your company
go ahead.
Is your company hired by lawyers?
We can be hired by lawyers who represent owners, or lawyers who represent the contractor, or lawyers who represent the surety. A surety is someone who bonds a contractor, and if he defaults, the surety has to prop up, come in and bail him out, and then he hires a new contractor to finish the job. So he's got some exposure too. And then there's subcontractors, there's suppliers, anybody who can be involved in the project can be sued or claimed for against the damages and delays. So we work for a host of people. We can work for owners, we can work for investors, developers, we can work for contractors, subcontractors, insurance companies, builders risk. If there's an accident during the project that causes a delay, a switchgear blows up just as about you're ready to start the project up. Now all of a sudden you've lost power and you're going to be delayed. Well, there's a builder's risk policy that covered that switchgear. So it's, I could go on and on and on, but it's what's kept me in this business for 35 years is every project always has to have some new angle that I've never seen before. There's the usual suspects on what goes wrong on projects. Drawings are late, you ordered the materials too late, the drawings are incomplete, you name it. There's a strike and they stop building, they stopped fabricating steel or whatever. I mean, there's so many different things that can happen that can cause delays. And a lot of these same things, are repeat customers on jobs. But, there's always a new wrinkle, which keeps it interesting.
Right.
And what I like to do about it is, you get to think as a lawyer because you have to apply the contract. You get to match wits with the opposing expert on the other side because if the owner's claiming damages against the contractor, well, he's going to blame everything on the contractor. And if I'm working for the contractor, I'm going to try to see where the owner was at fault. And, you know, as you would expect, you wind up with two ships passing in the night. Sometimes we agree. Sometimes we.
Oh, sorry. So in simple terms, if I put this in sort of really basic language, when there's a problem with a project that it doesn't get completed on time,
Right.
then people are upset on all sides, and they start pointing fingers at each other. It's your fault, you know, and you know, all the parties are pointing at each other, saying it's actually your fault, not mine. You get hired to come in to help figure out who's truly, or to the best of your ability, the person or the process that caused the delay. Either somebody made an error in judgment or made an error in ordering or delivery or something like that. So would that be a very simple way to say it? There's a delay and somebody's got to figure out why the delay occurred. And,
Right.
and you guys do that.
And, you know, it also could be progress. The contractor could just not be, he may have a duration of X days to do something, and it takes him X times 50% or whatever.
Right.
There's all kinds of things that factor into it. And, but you're right, it does need to be boiled down, because sometimes the delays are very, very apparent. Other times they're not. Even though I mentioned the CPM schedule that, you know, you run and it gives you the longest path. Well, as you've probably heard, with computers, garbage in equals garbage out. If you don't have a good schedule, and the output is going to be dubious. Unlike a lot of other things in engineering, where you have codes and design standards to meet, there are guidelines, but not any formulas to build a schedule. You know, you give it to 5 contractors, you may get 5 different schedules. Or, you know, or somebody may want to build north to south, somebody may want to build east to west, somebody may want to build clockwise, somebody may want to build counterclockwise. So, you know, you've got to assess the schedule first, understand it, and then analyze it. And we'll take the case where the project is late and it's completed, and then there's litigation thereafter. Litigation is the, you know, scorched earth, go after each other until you drop. It's not many of these cases actually go to trial.
Okay.
Many of them are handled through a mediation clause in the contract, which is a much easier and faster way. The level of proof and detail is much less. And the parties come together. The mediator doesn't make the decision. He tries to get them together and find common ground, find an answer that both parties can live with. There's an arbitrator who it's binding. He makes a decision and it's binding upon both parties. In that case, you present more evidence and more effort is put into it. And then, of course, there's trial, and I've been in trials that have lasted for months. By the time you get all the fact witnesses in and all the experts in, and you know, the cross-examination and et cetera, and it could go on for a while. Then the judge and jury has to make a decision, or the arbitrators have to make a decision. So you don't get an answer the next day because
what is
to swallow.
Can you speak a little bit about, like, what are the consequences or the outcomes of trials or arbitration? Is it pretty much financial? I mean, do people lose licenses for work? You know, what kind of things come out of these events?
Well, that's a good question, John. We don't get into the standard of care of whether the engineer did his design correctly. So we would never go and say, well, the structural engineer miscalculated the design for this beam. We don't get down to that level.
Sure. Okay. Right.
We're focusing only on being what we call forensic schedulers and forensic accountants. You know, forensics is those kind of, like, to draw an analogy today, is CSI. They're always trying to find evidence. or forensic medicine, you're always trying to do an autopsy and figure out why somebody died. It may not be as apparent until you get inside the body, you don't know. So until you get inside the schedule and relive the project retrospectively, you don't really know where all the dead bodies are and who caused it. And, a simple thing we do is we get in and, look at the causation. What was the cause of the delay? Who was responsible for it? And then price it. Say it was X days and X dollars. And we may need help on that. If we get into a differing site condition where they said there was going to be nice virgin ground and no rocks, and they start digging and they've got big boulders and there's a stream, underground stream running through it. The contract document said you wouldn't find that. And all of a sudden they find that, well, that's going to be a big delay. And we might need to engage a geotechnical consultant to say, well, was this a geotechnical investigation that's part of the design package? Was it done properly? And we don't comment on somebody's design. That's not our
Right.
daily.
But it's the time and the money associated.
The time and the
with
money,
it.
right?
Right. So it sounds like fines, that somebody will get fined or will have to pay a penalty of some sort.
Right. That's a better word, John.
Whoever is the person that is determined to be at fault or whatever the cause was, there's a penalty attached to it.
Right, and those penalties are like what are damages per day. Think about this: a shopping mall that's going to open up for Black Friday, and if it doesn't open till Christmas, think of all the money a lot of people have lost between Thanksgiving and Christmas. He may have to pay, the developer of the mall X dollars per day, or that power plant I was talking about, $180,000 a day. Well, the contractor, all right, it's determined to be his fault. Well, I mean, he's just not going to write a check for $180,000 times 3 months.
Right.
I mean, fight it, and it's going to be an analysis done. But keep in mind, say it is the owner's fault, and the contractor's there an extra 6 months. Well, for every day he's on that job, he's got people there. He's got very expensive bulldozers and cranes, and
they're not on some other job. They've not moved on to the next job.
So he's got his
there.
daily rate, his daily overhead rate of all those people, all that equipment, his trailers. I mean, even the water boy. I mean, it gets down to that level. I mean, and his daily overhead could be $5,000, $10,000, $15,000 a day, or $35,000 a day on a big job. So each day he's there longer, he is incurring these costs.
Right.
He's late, and it's the owner's fault. He wants to recover his what's called time-related damages. He's there that much longer. He wants to recover those costs of having all his equipment and people there.
Yeah.
And his home office overhead supporting the project as well. So you can see, as I said, time is money. It's money to many different parties.
Yeah. Yeah.
And,
Well, it sounds,
you have to allocate that.
Yeah. It sounds to me like your career has taken you around the country and around the world. So it sounds like you've had some travel under your belt.
Yes. When I first started, we were not in the tech age yet, and all the records were at the client's office. And if you wanted to do an analysis, you had to go to their office and go through boxes and boxes in the warehouse and have them all copied, and then they come back to your office. You got to sort through them. Oh, it was horrible. And then when you got into in the tech age, where everything is either on a server or a hard drive, or everything's scanned in, the schedules can be put on disks as well. All the cost accounting records are on the computer as well. That made it a lot easier. We get all the records that way, and then we can begin our work and work a lot faster. But sometimes you still have to travel to the job site to visit people or to interview people to actually see the project. Right. nobody wants to, first question when you're on the stand is, well, have you seen the project yet? And if you say no, well, then you're
Right.
biased.
Right. Right.
You're going to be, your credibility is going to be shot. Plus, you need to understand how the job was built. So, to answer your question, John, because of this work, I've been to 45 out of the 50 states. I've even worked on the Alaskan pipeline. So I've been up there. I never would have went to Alaska if it wasn't for the pipeline. And we also get, we've developed our clients such that we're getting a lot of international work. I've spent time in the Caribbean. That's nice. But I've also gone to other places that aren't as nice. I won't mention them, but I've also been to some really nice places like Dubai. There was a project, actually it was in Asia, but the offices of the owner or the contractor, pardon me, were in Dubai. So I was over there for quite some time, and some of the greatest civil engineering feats in the world are over in Dubai. One being the Burj Khalifa, the world's tallest building. I think designed by a Lehigh guy, if I'm not mistaken, more Owings and Merrill guy. While I was there, I took advantage of it. I went down to the Burj Khalifa with the attorneys, and we took a ride up to the top and saw everything. Then, I don't know the exact name of the project, but they have those man-made islands made of sand that extend out into one of the gulfs. That's another incredible engineering project. Got to see those. So, when you name it, we can, if there's a delay or a cost overrun, we can do it. And we'll throw our hat in the ring and try to do it. And a lot of times you get to meet some interesting people and see some interesting projects. And you got to learn how the project was designed and how it works in order to understand what caused the problems.
Sure. So if you're not working,
and
you're not traveling, what do you do around the house? What's your,
around the house?
Yeah.
Well, I'm proud to say that I've raised 2 children, sent them both to college. They're both married now. My son is a legacy. He went to Lafayette. And now I'm become a grandfather.
Oh, nice.
3 times over, with a 4th due by Labor Day, no pun intended. But what I like to do around the yard as a good stress reducer after a long week of thought and analysis and pondering over all these issues and problems, because every project has these issues. It's not cut and dry. It's not like sum of the moments equals 0, and you can check your work. Your numbers have to add up, but you only get reasonableness checks. You don't necessarily get the same things like math checks or engineering checks. So I'm out in the yard. I'm constantly building things and expanding my yard, or as my 4-year-old grandson says, well, Poppy's out breaking trees.
So do you have acreage? Are you on a?
Yes, I've got 3 acres.
Okay.
And one of the things that happened when we first moved in, we live out in the Blue Ridge Mountains, is there's no underground water drainage system. Half the cul-de-sac drains through swales that go through my yard. And when the spring rains came, I had some heavy flow going through my backyard, and it would route things out. And by then the contractor was long gone. And I had partially caused the problem by clearing and grubbing a lot of the area the water went through. So I sort of created the problem, and I've spent a lot of time fixing that problem. It didn't work the first time or the second, but Mother Nature is a challenge. Water finds its own way, but I think I finally have a solution, and it also looks good. So I'm quite proud of that.
So this is an interesting aspect of being a civil engineer, and because civil engineering projects are out, you see them. People may not always look at something and say there's a civil engineering project, but they're all around you. So we live in a new neighborhood, and before building here, I came down, and on rainy days, I sat in my car and watched the water flow down the road. Oops, sorry. Watch the rainwater flow through the streets to see exactly where it went, to make sure that I did not end up in one of the properties where the water was collecting from the neighboring yards. So, I don't know, for all the years of schooling and whatever, I guess it's a little bit of a benefit that you have this thought that, hey, before I build on a piece of property, I can go out there and observe it to make sure that I'm not going to have any issues. So it's or if there is something, you've got some knowledge that you can fix the issue. So.
Right.
So all that money that we spent to become civil engineers is paid off in our ability to manage our property.
Yes, and to not make stupid mistakes. You get smart by being stupid. I mean, that's.
Well, I feel sorry for them. I mean, there are some people in my neighborhood where the water is draining down the street and right into their driveway.
Oh.
But there's nothing that they can really do about it now. But that was one thing that I came down to watch, just to see where water was flowing. So, well, Scott, 30 minutes come and gone already, really fast. Actually, probably a little bit more. But it was really enjoyable talking to you, catching up, hearing about the work that you do. This is one of those fields where somebody would say, I can do this with a civil engineering degree. This is a part of, this is a career path for me. And that's one of the great things about having people like yourself on, is to, enlighten others that when you go through a career, you get an undergraduate degree in civil engineering, it doesn't mean that you're going to be, a structural designer or anything along those lines. There are a lot of career paths out there that are just, not sort of out in the forefront that people would necessarily be aware of. So I appreciate you bringing some of this to light and helping those that aren't aware to be aware of these kind of opportunities.
Yeah, I would like to add, that's a great point to wrap up, John.
And you may want to lift that T-shirt or your shirt up there.
Yes.
Tip your camera down a little bit.
The thing, about the reason I enjoy it is because I have this engineering background and problem-solving technique, and that's what it takes. I mean, you've got these tough cases and these tough issues, and you got to work through them. And having that sound engineering degree and logical thinking, plus the ability to understand, what it takes to design and build a construction project is very valuable.
Yeah.
So, I mean, for somebody to say, well, why do I have to get all these, take all these courses then to get into construction? Well, that's, you need that sound thinking and understanding of the basic concepts.
Yeah. And I would say that I think a lot of engineering is about problem solving.
Right.
And you don't want to get caught up all the time in the computations. And you want to think of this on a bigger scale. You're trying to solve a problem. How do I go about solving this problem? And if I have to use a formula to do it, so be it. But don't get caught up in the formula. Think of the bigger issue is trying to solve a problem. Help somebody figure out how to solve a problem. So, well, thank you, sir. Appreciate your time. Enjoyed it tremendously. I'm glad you were one of the guests here on Let's Be Civil podcast. And I know we'll be talking more, especially now that you've figured out how to use Zoom. We won't comment on your Zoom skills in the interview here. We'll do that more offline. So we'll talk to you soon.
Okay, thanks, John.
Yep.